Okay, 4.2, linear and nonlinear functions. Probably pretty obvious what linear and nonlinear mean, but here's some definitions for you. A linear function is a function whose graph is a line or part of a line. Um, there we go. So we have a full line here, we have a full line here, and this one's just part of it. So you can see that the points are all lining up into a straight line. Then what do you think nonlinear means? Super tricky. A function whose graph is not a line or part of a line. And there's some examples of those. So these are not perfectly straight lines. You can see on the third one, part of it is a straight line, but this part is a different straight line. So linear versus nonlinear. The easiest way to tell if a function is linear or nonlinear then is by looking at its graph. We will have to be able to tell linear and nonlinear based on other things other than graphs, though, as well in this section. Remember in the last section, you had to find rules given a chart, and what I had you do was find the differences in each one. Okay, so after you find the difference between each of these, then you are taking your output over your input. What this really is a rate of change. A rate is a comparison of two different numbers, which is what we're doing. We're comparing this number to this number, and we're comparing the rate at which they change. Rate of change, which you should also recognize as a different term for slope. Okay, so that is why when we start writing our equation, if you notice, we're in y equals mx plus b form, and that number that we're finding, that rate of change, it's your m, it's your slope. Okay, everything we did in 4.1 was linear. We're going to keep working with some linear ones, but we're also going to throw in some nonlinear. So first of all, based on a chart, we have to figure out if we are working with linear or nonlinear information. The way you will do that, you're still going to find, you're going to look for a common difference. Okay? You're looking for a common rate of change. So from here to here, you're adding 2. Adding 2, adding 2, adding 2. Remember, they don't always have to be that way. It's okay if they're not always the same number. Over here, let's see, I'm doing in my calculator 50.27 minus 12.57, and I get 37.7. Over here, I have 113.1, and I'm subtracting 50.27. So I had to add 62.83. Well, obviously, those are not the same number, okay? And that's okay. Let me do one more of these. 201.06 minus 113.1 plus 87.96. So I'm getting different numbers each time. But that's not what is important. What is important is that your rate of change be the same. So if you're looking at your rate of change, you have 37.7 for the first one over 2. 37.7 divided by 2 is 18.85. Do it with the next one. We have 62.83, and it is over 2. Well, obviously, that's going to be a different answer. That is actually 31.415. So we do not have a common rate of change. The rate of change is different from this first point. Let me use a different color. The rate of change is different from this point than it is from here to here. Okay, so we're getting two different rates of change. That means it's nonlinear. To be linear, it has to have the same rate of change between every single point. And remember, we're talking about this as an ordered pair, this as an ordered pair, etc. So if you have a different rate of change from here to here, as you do from here to here, it has to be nonlinear. Okay, on the sauce cost then, when this was about pizza, on this one, go ahead and find the differences and see if you have a common rate of change on it. Okay, I went ahead and did that, and I got all plus 2's over here and all plus 0.8's over here. That's not what's telling you, though. Remember, what you're actually looking for is the rate of change, which is found by taking each of these over the corresponding one of those. It's your increase or decrease in your y values divided by your increase or decrease in your x values. It's like a rise over run, a slope, otherwise known as a rate of change. So each one of those comes out the same. They all are 0.80 over 2, which is 0.4. Okay, so this one is linear, and we can write the equation. We can say that y equals 0.4x, and then you just have to figure out if you need to add or subtract a number, which is essentially going to be your b. The way you do that is you just pick one of these x and y values and plug it in and check it. So here I would have 0.80 equals 0.4 times 2 plus b. This is 0.80 equals 0.80 plus b. Well, if I subtract 0.80 on both sides, then I would have 0 equals b. So that means I didn't have to add anything at all. B was just 0. So this is linear, and the equation is y equals 0.4x. So this is really a review from 4.1. This is new in that we're finding out it's nonlinear because it's not a constant rate of change. Here's the graphs of each of those. If you were to plot these out and graph them, you can see that this first one definitely is nonlinear. Based on the graph, it is not a perfectly straight line, it's a curve, and this one is a perfectly straight line. Okay, so we now know how to tell if something's linear or nonlinear based on a graph and based on a t-chart or a table. And now we need to know how to do it based on an equation. And the big thing is, in order to be linear, it has to be able to be written in the form y equals mx plus b. If you cannot write it in this form, then it must be nonlinear. Okay, so let's just go through and figure out what we think on each one. So on this first one, can you write this in mx plus b form? And the answer is no, because this x is in the denominator. We can't have x in the denominator, so that must be nonlinear. The next one, this should look familiar. You've seen this many times. This is not in y equals mx plus b form, but you could easily get it there by subtracting 2x and then dividing by 5. Y equals negative 2/5 x plus 8/5. Okay? You've done this a million times. That form is called standard form. Standard form is still of a linear equation, can be moved into slope-intercept form. Y equals mx plus b, so that is linear. This one is slope-intercept form, exactly as it's written. Okay? This next one, does that look like y equals mx plus b? This part does, but this part is not. That has a square in it. If you have any exponent in there besides invisible 1 exponents, then it has to be nonlinear. This is absolute value. Absolute value is always nonlinear. If you graph it, that's how you get one of those V graphs. We see an exponent right here, so that should be a dead giveaway that it has to be nonlinear. And then finally, y equals 4. Linear or nonlinear? Well, I don't see an mx, I kind of just see a b, but that just means that your slope would have been 0, because 0x would just be 0, it would go away, so that is linear. So take a look at what has to happen in order for it to be linear. It has to be able to be written in y equals mx plus b form. Anything else would be nonlinear. So some things that definitely make it go nonlinear are exponents in the denominator, or I'm sorry, variables in the denominator, exponents other than 1, and absolute value. Okay, so look out for those things. If you see those in an equation, you know they're nonlinear. All right, so we need to review writing function. So we've already done this with the linear ones in the last section, but I want to go over it a little more because I think, and we already did in this video, but I think you guys could use some extra practice on that. So the first thing in order to write a function rule is decide if it's linear and nonlinear. If it's linear, then that's just the same way we did it for 4.1. You need to think about y equals mx plus b. If it is if you're thinking in linear terms, then you need to find the rate of change, which is what we were doing with finding the change in the y's, find the change in the x's, and then divide them. Should be a common rate of change for each one. And then figure out if you have a b, what it is, what you need to add in order to make your equation work out. And that's just by plugging in that first test point. If it's nonlinear, this is the new part, you need to be thinking exponents. Okay, I'm not going to give you anything super crazy. They're going to give you ones that you'll be able to find and actually write out the function rule. But it's exponents is what's going to make something nonlinear here. Two different ways you can try exponents. You can have your exponent be an x and some number on that, or you can have x be the base and put some number in the exponent. So write this down, make sure you have this. These are your two things you're going to want to try. Now in both of these, you might end up needing to, oh, I don't want a highlighter. You might need to be adding some number or subtracting a number here. That can always happen, so look for those. Okay, so working on writing these function rules, you want to first see if it's linear or nonlinear. In order to do that, you're going to do exactly what we've been doing the whole time. Figure out if you have a constant rate of change. So here you're adding 1, here you're adding 2, and here you're adding 3. Okay, over here you are adding, you would subtract these two numbers to find that out, you're adding 92. 1403 minus 1219, we added 184. We don't know this number, so I'm just going to continue to leave that blank until we figure out our function rule. Okay, so find and see, look and see if you have a constant rate of change. So your output difference over your input difference for the first one is 92 over 1, which is just 92. For the second one, it's 184 over 2, this number over that number, which is 92 as well. That means we do have a constant rate of change, which means this is going to be linear. If it's linear, you already know how to come up with your equation. It's going to be y equals something mx plus something else, right? We're just going to fill in for our m and our b. You've already found your m. Your m is that constant rate of change, which is 92. Then we just need to see if we need to add a b or not. The way you do that is plug in any one of your ordered pairs. This is an ordered pair, this is. We know our input is x, our output is y. I always tend to choose the first one. It doesn't matter though, you could choose any of them. So if I choose, ooh, what did I just do? So if I choose that first one, my y is 1127 and my x is 0. So 1127 equals, well, this would be 0. 0 plus b is just b. So that tells me that my b is 1127. That means my final equation for that problem is y equals 92x plus 1127. If you're not 100% sure if you've got it right, try another one. Plug it in and see if you get it to work. So now I'm going to choose this next one. My y value is 1219. My x value is 1. So I want to know, left side is 1219. What's my right side? 92 times 1 plus 1127 is also 1219. So that should indicate to you that you have your equation correct. So your function rule for problem 1 is right here. The rest of the problem says to finish the table. Well, I have a blank right here. I know my x is 6. I just need to find my y. All you have to do is plug in. Plug in what you know. I don't know my y. I'm plugging into my function rule. That's a star. 92 times my x is 6 plus 1127, and it's just a matter of calculating it. 92 times 6 plus 1127 gives me a y value of 1679. Okay? You've done this before where you plug in your x to find your y. No big deal. It's just you had to come up with the equation first. Okay, let's look at the second problem. All right, so first thing you want to do is figure out if this is a linear or nonlinear problem. I'm actually going to take this and put it on a different page so that I don't have all that mess going on. Get rid of that plus 92. Okay, so on my left side, on my input, also known as my x's, I have plus 1 here, going from there to there. From 2 to 3, I added 1. From 3 to 4, I added 1. From 4 to 5, I added 1. On my right side, well, from 1 to 8, I'd be adding 7. From 8 to 27, shoot, I'd be adding 19. Well, because these are all plus 1s, as soon as I get this different number, well, my first one, my rate of change would be 7 over 1. But my second one, my rate of change would be 19 over 1. That indicates to you this is a non-linear problem. If you don't have the same rate of change each time, it has to be non-linear. Okay? So that's when we need to think about nonlinear, we need to think about exponents. Okay? So let me get rid of this. Well, let me leave that there for a second. Sometimes you could, no, I'm going to get rid of it. Talk myself out of it. Sometimes you can add, instead of adding, you could multiply by something to get the next number. Here you would be multiplying by 8. Is 8 times 8 going to be 27? Nope, that didn't work. Okay, so at that point, the best thing you can do is look from your x to your y. What could you do to x to get your y? Using exponents. Okay, so if I'm thinking exponents, and I have a 1, and I need to equal 1, well, I could put 1 to any power at all and get 1. So maybe that's not the best option to look at. Let's look at the next one. What can I do with 2 to get 8? Well, I know 2 to the third power is 8. So would that work for this one? Could I take 3 to the third power and get 27? Bingo. Okay, so that's indicating to me what I'm doing is I'm taking my x value to the third power to get my y value. In other words, y equals x to the third. Okay, so you just need to start thinking about exponents when you're looking at nonlinear functions. You should still try to see if you need to add or subtract anything, but we know that we don't on this problem. It is good to go. They've given us this y value. We need to finish the table right here with the x value. So you're just plugging 512 in for y. Well, if 512 equals x to the third, what number cubed is equal to 512? You could do some guess and check to figure that out, and it wouldn't take you too long. You would find out that it is 8. Okay, so continuing that chart on, 8 is your missing number. Here's your equation, and there's your missing number. Okay, back to this last one here. Okay, figure 1 has 3 branches. Notice what's happening. Figure 2 has 9 branches. Figure 3 has 27. We want to fill in the rest of the chart. So when figure number 4, figure number 5, and what number figure would have 2,187 branches. So first of all, we need to figure out, is this linear or nonlinear? Up here, I'm doing plus 1s every single time, right? Here, I added 6. Here, I added, what, 18? Well, 6 over 1 is definitely not the same as 18 over 1, so that indicates to me this is nonlinear. If it's nonlinear, I need to start thinking about exponents. Whoops. Okay. Besides adding 3, what could I do to get from 3 to 9? Or besides adding 6. Did I put add 3? No, I had add 6. I could also multiply by what number? 3. Does that work here? Yes. Okay, so I have a pattern. It's not adding though, it's multiplying. When you have a pattern like that, that means when you write your equation, when you write your equation, that number is going to be the base of your exponent. Your variable x goes on top. Okay? So if you are multiplying by the same number each time, that's the base of your exponent. So we have two different ways that we just came up with exponent or nonlinear functions. One, this one right here, your base is an x, and over here, your exponent is an x. So you're still working with exponents on both of those problems. It's just one of them, your variable is the base of it, and one of them, your variable is the actual exponent. Either case can happen, and that's what I was talking about right here. Okay, it's either x to some number or some number to x. All right, so using your function rule that you came up with, you're going to solve to figure out the rest of your chart here. So for your 4 here, you would be finding y equals 3 to the 4th power. And 3 to the 4th power is 81. You also could have just used your times 3 pattern here. Either way, it doesn't matter. Y equals 3 to the 5th or 81 times 3 gives you a value of 243. Okay, do 243 times 3 right here. 243 times 3 is 729. So if 729 were here, then we could put a 6, but that's not 729. So don't think that we're just going to follow this pattern here and put a 6 here, because the pattern doesn't work down here. What you can do instead is you could either plug this in for your y, so you'd have 2,187 equals 3 to the x, but we don't know how to solve that yet, and you won't learn till Algebra 2. So instead, what you need to do is just keep multiplying by 3 until you figure it out. So I already said that when I multiplied this by 3 here, I got 729. That would go with 6. So I could like add another column here and say 6, 729. Or, and then you could keep going, multiply by 3, see if that'll do it. And you'll find out that it does. So this is actually 7. The other way you could do it is just guess and check this. Type in different numbers for the x until you figure out what number, 3 to what power, is going to give you the 2,187. Okay, so just a little bit of guessing and checking there. Okay, pause the video, you guys figure this one out. Okay, answer to the first part, it is nonlinear because I have 4 different rates of change. So knowing it is nonlinear, pause the video again if you have not figured it out and try and find the function rule. Okay, I noticed that I had a pattern going down of multiplying by 2. So that becomes the base of my exponent, and my exponent is the variable x. Pause the video, do this problem. Okay, you do not have the same rates of change, therefore it is not linear because it does not increase by a constant amount compared to x. All right, last problem. Complete the first table so that f of x is a function and so that the second table is not a function. We're going to talk more about this notation later on in this chapter, but for now you can just notice that this is your input, this is your output, this is your input, this is your output. This is a bit of a throwback to 4.1. To make things a function, each x can only have one y. So it does not matter what number you put here. It doesn't matter what number you put here. The only things you cannot put here to make it a function would be -1 or 6. If you put any other number here, this is a function. Go ahead and pause the video and make this one not a function. Okay, you would have to make that box either -1 or 6, and you would need to make this something other than -8. Okay, go ahead and finish your packet now.